Hello everyone, welcome to another video from the tutorial series Aspen Plus Mastery and Certification. My name is Tabish. Today I'm starting second part of this tutorial series. In the first part, I emphasized on the properties environment of Aspen Plus. In the second part of this series, my emphasis will be on the process simulation of different unit operations involved in the chemical engineering. In today's video, we will have a detailed tour of the simulation environment and learn how to create and manipulate the flowsheet. So let's open Aspen Plus and start the tutorial. When you open Aspen Plus interface, you first enter into the properties environment where you can define the components and the thermophysical property method. Also, you can use NIST Thermodata Engine to retrieve the experimental data of pure components, binary systems, and tertiary systems. Also, you can perform property analysis of the pure components, binary systems, mixtures, solubility, pressure temperature envelope, ternary diagram, and residual curves. You can estimate the missing property parameters, and also you can perform the regression to determine the model parameters using the experimental data. In the previous videos, we have gone through all of these sections in detail. If you want to learn any of these features of the properties environment of Aspen Plus, you can watch the previous videos. Since in today's video, we'll shift to the simulation environment, and for the sake of this tutorial, let's add three components including water, acetone, and NMYBK. That stands for methyl isobutyl ketone. Also define an appropriate thermophysical property method. Let's select NRTL. Click Next. These are the binary interaction parameters corresponding to NRTL method. Let's run the properties environment. Results of the properties environment are available. Let's switch to the simulation environment. At this moment, please don't forget to save the file. Let's save the file with the name lecture 2.1. So this is the interface of simulation environment. You can notice that this is slightly different from the interface of properties environment. At the very top, there is a quick access toolbar. You can activate or deactivate any of the option from the quick access toolbar. Then there is a menu bar. Currently, we are under modify flowsheet menu. Here you can see different ribbons associated to flowsheet modification. Then there is another option of format menu where you can modify the flowsheet, including changes in the font, insertion of different shapes including arrows, circle, rectangle, also the text box. But mainly in the simulation environment, you will be working with the home menu. The most important options in the home menu are regarding different run options, selection of appropriate unit system, then the display of result summary, input summary, history of the simulation, and report. Also, options regarding the flowsheet analysis, including sensitivity, data fit, azeotropic search, distillation synthesis, and currently deactivated heat exchanger and stream analysis options are given. Then there is a ribbon regarding the safety analysis and couple of options regarding artificial intelligence based simulation of the process. Below menu bar and the ribbon, you can notice boxes with the different colors. These are termed as the activation dashboards. That includes dashboard for the economic analysis, energy analysis, heat exchanger design and rating, and equivalent CO2 emission. It's possible that when you open Aspen Plus simulation environment, these dashboards are rather expanded, but you can collapse these dashboards with this small arrow icon, or also you can get rid of the dashboard by turning it off. In the left part, you can notice the navigation pan, and you can clearly notice that this navigation pan is way different than the navigation pan of the properties environment. At the very top, there is an option of global settings. I will go through these options later, but below the global setup, you can see property sets, options for the results analysis. Here you can define the flowsheet sections. All the streams defined in the process flowsheet will appear in the stream section. All the unit operations defined in the flowsheet will appear in the block section. Also, you can notice the options of sensors, utility streams, reactions, and there is a very important option to notice the convergence and define the appropriate methods and convergence configurations. Below convergence section, there is a folder regarding flowsheet options. Here you can define the design specifications, introduce calculator, transfer the streams, stream library, balance, measurement, pressure relief, Below, you can notice the model analysis tools, including sensitivity analysis, optimization, constraints, and data fitting. One of the very important feature in the simulation environment is regarding the artificial intelligence. Here you can use the live plant data to train the model using machine learning features and improve the overall reliability of the simulation. Similarly, at the very bottom, you can notice the status of current flowsheet simulation, and at the right bottom, you can notice the zoom options or the option to fit the flow sheet into the entire window. Here is the window where you define the flow sheet, and at the very top of the window you can notice the help regarding any of the feature of the simulation environment. Another important menu in the simulation environment is the view menu. Here you can show or hide different options related to the flow sheet and simulation. For instance, you can show the activation dashboard that currently we deactivated from this cross button. You can hide or show the activation dashboards. Also, you can show or hide model palettes. Model palette in the simulation environment is a section where all available unit operations are grouped into appropriate categories, including mixer separators, exchangers, columns, reactors, pressure changers, manipulators, and dedicated sections for the simulation of solids and for the batch models. The streams required for the flow sheet are grouped over here. Here you have the material stream, heat stream, work stream, and in the latest versions of the Aspen Plus, there is a separate stream concerning the electrical power. Similarly, there is an option of flow sheet view and hide option. If accidentally you delete the flow sheet section, then you can get it back by pressing this flow sheet option. That will bring back the currently active flow sheet and you can modify the flow sheet. So let's learn how to draw a process flow diagram in Aspen Plus. For that purpose, you will need streams as well as unit operations. For the sake of this tutorial, let's draw a very simple process flow diagram that includes mixing of two process flow streams with one product stream. For this very simple process flow diagram, you will need a mixer block and two material streams. In the mixer splitters model palette section, you will notice a mixer block, another block indicating the name F-split, and another block indicating S-split. F-split for flow splitter and S-split for substream splitter. We'll come back to the details of these two splitters in the upcoming videos. But for this tutorial, let's add a mixer. Before adding a mixer to the flow sheet, you can notice different icons corresponding to the mixer block. Since mixing can happen in multiple ways in the process flow diagram, for instance in a hopper or in a screw mixer or simply in a tank or in a venturi or in a valve, there can be work stream mixer or a heat stream mixer or process flow stream mixer. There can be a T for the mixing or a three-way type mixer. Consider that the mathematical model remains the same for all these mixers. They only differ in their appearance and the connection ports. Let's pick a very simple triangular type mixer block. You can notice that as you selected the mixer block, a green border appears across the selected icon. Go to the main flowsheet window. You can notice that now the cursor has turned into a cross that indicates that some unit operation or a stream has been selected. You can left click to add the block. It will pop up to enter the name of the block. Let's add mixer as the name of the block and hit OK to enter the block. Still, you can notice that the cursor is turned into the cross. If you want to get rid of this cross, then you can either right click from the mouse or you can go to this arrow icon to cancel the insert mode, or you can press escape button from the keyboard. All the three options will get rid of the selection. Let's click the material stream and bring it to the main flowsheet window. As you enter the main flowsheet window, you can notice arrows with different colors are active now, and arrows indicate the connection ports. The red arrows indicate the required connection streams and the blue arrows indicate the optional streams. You can hover the cursor over the port to see the details of the connection port. For instance, this indicates the required feed stream. Here you can insert one or more inlet streams. So once you are over the connection port with the cross active, left click and hold with the cursor to move the connection port to the desired location. Once you are happy with the position of the connection stream, then you can unpress the left click of the cursor and you will be given option to click anywhere on the main flowsheet window. A pop-up window will appear to add the name of the stream. Let's add the name of the stream as F1 and click OK. Still you can notice that the cross is active for the cursor, that indicates that you can add another material stream. To add another material stream as the inlet stream, go to the same inlet port, press and hold left click. Now you can drag the cursor to the required position, and once you are happy with the position of the inlet port, you can unpress the left click and you can enter anywhere on the main flow sheet to enter the second inlet stream. Let's name it as F2. Click OK. And also you need to enter the product stream. For that purpose, go to the outlet port, left click and second click anywhere on the window. So here you can enter the name of the other stream. Once this is done, you have the option to hide the model palette. For that purpose, you can auto hide, so that when you are required, you can get it back by clicking this model palette button, or it will automatically hide again. Next, you can fit this flow sheet to the working window. For that purpose, either you can right click and go to this zoom to fit option, or you can go to the very right bottom where you can hit it and it will automatically zoom to the entire window. There are multiple other options to better present the flow sheet. For instance, if you are not happy with the size of the mixer block, you can select it, go to this very right bottom corner, and here you can increase or decrease the size of the block. Alternatively, you can use the shortcut keys to increase or decrease the size of the unit operation. If you are not happy with the icon and you want to change the icon of the mixer, you can right click and exchange the icon. If you are not happy with the position of the connection point, simply hold the stream from the connection point and move to the desired location. Also, you can notice a couple of other options for the flowsheet modification. For instance, if you want to rotate the stream or the block, you can simply select it and go to the rotate option. It will rotate the corresponding stream or the block. You can also flip the block horizontally as well as vertically. Or you can do the same by right click and rotate icon option, where you have the option to rotate left, rotate right, flip horizontal and flip vertical. Let's rotate right to get back to the previous options. Also, you can straighten the streams as they are not currently straight. So for that purpose, just simply click the stream. Either you can manually move it, or there is an option to align. It will automatically align the stream and the blocks. Alternatively, you can press Ctrl A to select all the flow sheet and then align it once. It will align all the streams to the blocks. Also, you can try option of reroute streams. You can notice the shortcut key as Ctrl J for the reroute stream and Ctrl B for the align stream. This is particularly important for the simple flow sheets, where you can select all the flow sheet and press Ctrl J and Ctrl B. That will automatically align and reroute the complete flow sheet. Besides adjusting the flow sheet, you can notice a couple of more options in the modify menu bar. One of those options is 3D icons. This option switches the display of icons between 2D and 3D styles. If you do not want to show the 3D icon, then you can uncheck and the block symbol will turn into 2D icon. Also, you can show heat, work, power results, temperature, pressure, vapor fraction results, as well as the flow rate results corresponding to the block or the stream, and for that purpose just choose the appropriate option. In the format menu, sometimes this is very handy to show different sections of the large flow sheet, and for that purpose you can choose to draw a rectangle or free polygon or a polyline for the relevant section. You can also add the text to label the specific section, or simply if you want to annotate the flow sheet. For instance, if I want to show the label of mixer example, so it will add the title or annotation to this flow sheet. You can select and change the font size, font type. You can bold, italic, underline, or even change the color of this annotation, and you can change the alignment. So these are different options to draw and modify the flow sheet. Now if you move to the navigation pane, all the streams of the flow sheet are grouped into the folder of streams, and the blocks are grouped under the blocks folder. Currently F1 and F2 streams are highlighted with the half red circle that indicates that F1 and F2 streams need specification for the simulation, and unless you specify F1 and F2 streams, the Aspen Plus will not be able to solve this problem. This is also mentioned in the status bar as required inputs incomplete. Whereas for the mixer, no default information is required for the simulation purposes. In the next video, we will have a detailed discussion about the degree of freedom of the mixer and similarly other blocks of the mixer separator model palette. At this moment, let's have a look into a couple of other settings in the simulation environment. One of the very relevant setting is the global specification. Here you can enter the title of this simulation. Let's add a title to this flow sheet. You can change the units between the default unit sets that includes engineering, metric units with bar as pressure unit and degree Celsius as temperature unit. You can change the mode of the simulation between steady state and dynamic simulation. You can change the stream classes between conventional or mixed stream including solids. We'll come back to the specifications of different classes in the upcoming videos. You can change the flow basis between mass, mole and standard volume. Also, you can refer to the ambient pressure. You can globally define the valid phases, whether the free water is present in the simulation, or also you can define the operational hours in a year. Similarly, you can add some description to this simulation file and couple of other options regarding accounting, diagnostics, or you want to have the additional comments attached to this file. In the calculation options, you can uncheck the option to perform heat balance calculations or calculate component molecular weight from the atomic formula, or you want to add the specific molecular weights by yourself. By default, Aspen Plus calculates the molecular weight of the components from the defined atomic formula. One of the very important option is to use the results from the previous conversions pass. So for every new run, Aspen Plus uses the previous conversions results as the initial guess for the next calculation. If you do not want to include the previous convergence results for the next run, then you can uncheck this option. Also, you can uncheck bypass property set calculations if flash calculation fails. Use analytical property derivatives, required calculations of molar flow derivatives, and so on. These are the global settings for the flash calculations. In the model options, there are some critical global settings to important unit operations, including compressors, multi-stage compressors, Gibbs reactors, and red flag columns. And you can notice that these important tunings include the number of iterations, tolerance limit, and particularly in case of red flag columns, the default algorithm for the calculation, and whether you want to apply a damping factor for the red flag convergence. And similarly, there are other options related to heat-x, heater, multi-heat-x, and reaction kinetics. You can choose the global settings for these unit operations. And similarly, you can view a couple of other settings for the check results, system, limits, and the reactions. There are few tunings for the CO2 emission calculations, and one of the very important global setting is regarding the stream classes. If you are dealing with the solids, you can change the stream class between conventional and the mixed stream class, and you can specify the substreams for given stream class. You can scroll other settings in this section as well. In the stream groups, you can change couple of settings for the streams appearing in the flow sheet. For instance, the default summary template attached to those streams, the color of the stream. You can switch between any of the color, assign certain weight to the stream, or you can change the style of the stream. This is very handy for the large flow sheets, or if you want to assign a specific formatting for a certain stream. Especially in case of TS streams, one of the features that I will particularly emphasize is the unit sets. The default unit sets are given over here. If you have selected a default template while starting the simulation, then there might be a different unit set appearing in this section. Sometimes it is particularly important to define a customized unit set depending upon the type of the process you are simulating. For that purpose, you can start a new unit set. You can copy the units from any of the default unit set and adjust the units by your requirement. For instance, if I want to have most of the units as of the metric unit set, but I want to change the temperature to degree Celsius and pressure to bar. And similarly, if I want to have a specific unit set for the enthalpy in joules per kg, enthalpy flow in kilojoules per second, or so on. And also, I want to customize the units of other thermophysical properties or the currency, or I want to fix some miscellaneous units. Then I can fine tune this unit set and set the default unit set to the newly created unit set. So it will apply the customized unit set to the complete flow sheet. Also, let's have a look what other global settings you can define for your simulation. You can either go to the file and go to options, or alternatively you can go to the customized and choose the options from here. Here you can select the settings for the simulation run, associate a specific template for economic evaluation, define how the simulation should run. Similarly, couple of settings for the property basis. You can set a default databank search order and property options in this section. Also, you can decide how the binary information should be searched for different property estimations. You can apply some settings for the file formats. See some options for the flowsheet. Here you can set default styles for the flowsheet, including measurement units, number of significant figures for the results shown on the flowsheet. One of the very relevant setting is whether you want to have automatically assigned block name with the prefix as B, or you want to change it to some other prefix letter. Also, if you want to automatically assign the stream names with a certain prefix, you can check other settings regarding appearance of the flow sheet. There are a couple of settings for the plotting, for compatibility, and some advanced options. Also, if you want to turn on or turn off the activation dashboard as the default settings. So once you are done, you can apply the settings. Besides all these settings, let's have a look what other options are available for the flow sheet. Go to the view menu. Here you can view the scale for this flow sheet window. Also, you can show the grid. You can adjust the grid. You can set the page breaks or even reset the page breaks. If you want to print the flow sheet, you can go to the file option. Here is the print option. You can set up the page for printing, directly print it, or preview before you print. You can print the flow sheet as a PDF file, or you can send the file to the paper printer depending upon default printer in your computer settings. In this tutorial, we had a detailed discussion about the simulation environment. Also, we have learned how to create and manipulate the flow sheet. For the further practice, I will suggest creating the following flow sheet. This is a typical flow diagram for the ethyl glycol production process. Draw this flow sheet and slightly tune the process streams of the flow sheet. Change the appearance of inlet streams to green color, outlet streams to blue color, and TS streams to red color. By drawing this flow sheet, you will thoroughly learn how to draw a flow sheet in Aspen Plus. In the next video, we will learn how to simulate different unit operations from the mixer splitter palette, including mixer, flow splitter, and substream splitter.